contextualized language, and so it's one way of describing things. You know, you can use it between tools like we talked about, and we can make it work in different parts of the life cycle.
So let's see, Ryan Gerard and Ramya of Symantec had introduced the concept of test reputation-based systems or vulnerability reputation-based systems. Basically, it was seeing what the testers, what they found, put it against the developers. So it created two goals for testers and developers. Testers to find more bugs among their peers, and for developers to write better code. And that's part of watching and listening.
So yeah, I'll go into that. Sure. So if you're going to work with other people, I think it's great. Like programmers had this whole thing in Agile where you do pair programming. It didn't really work out that well, and some people still do it, but it's not really that popular. But pair testing is more popular, especially when you're testing for like web application security vulnerabilities, or even just any type of software pen testing, period. You know, at runtime, working with another person is good. So you know, collaborating and watching what they're doing and listening to what they're doing. There's something called the Think Aloud protocol, where you just say what you're testing and just like make it well known that you're actually doing something, and talking about what you see and what you're experiencing. That's a good way of doing this. Then there's also recording. So like we talked about capture replay, which is kind of like recording, but I'm thinking more in terms of like taking a video of like what you're doing and putting it on YouTube, or like integrating with someone with Stickam. Like you got something watching your monitor and they got something watching theirs, and you can see each other's monitors. Like Screen used to have this functionality. You can like share screens in all sorts of different ways. I think VNC supports it. So doing that sort of thing, and then like recording like what you're saying as well. So like it could be useful in a podcast later. Imagine like doing like testing, security testing like in a podcast type format. I think that would be interesting. And then, so we already talked about script, data-driven, and table type testing. You want to measure all these and kind of like get the reputation. See what the metrics are and how you compare to everybody else, and kind of like increasingly get better and kind of like learn from your friends, learn from your coworkers on how to do better security testing. Another way that's really interesting that I found out about recently is called exploratory testing. I actually heard about it before, but I hadn't really explored it that much in depth. But it's really interesting. Most waterfall type models have all these test cases, and they're really heavy from like the requirement side. And you design all these tests way beforehand, and a lot of times they miss security. So a good way to integrate security into the SDLC late in the process, especially, is to use exploratory testing, which has like a test charter. And the idea is you're writing the tests as you're actually doing the work. So you're basically like hacking the websites, like using the injections, using these types of testing tools, and using your brain to figure out what you want to attack. But at the same time, you're kind of like learning about the application and how it works, and writing down ideas of like how to just test other things. This works especially well with like MITRE's KPEC, where you have like attack paths, and so you can change your attack paths based on what you see in the application, while you're testing it. And so if we measured all these things, if we measured testers and we measured our test cases, we could probably determine what are better tests to do, and better people to use for certain types of tests. So I guess in order to increase the coverage of your testing and your test results, I came across this new concept called combinatorial explosions. It's actually probably been around for a while, but I think there were books about it in maybe as early as 2003. The basic idea, and I think that every single security person probably gets this and has experienced this. And so I know Gary McGraw talks about it in his book, Exploiting Online Games. He calls it combinatorics. And basically, if you induce lag in an application like WoW, you can probably like duplicate items. There's this website www.wow-dupe.com where you can go and see how to duplicate items. This works especially well in web applications too. That's what's funny. Like you could basically cause synchronization issues to where you're overloading the application, but at the same time you're checking to see if there's a race condition like time of check, time of use. You could test for deadlocking, live locking conditions. There's a particular testing technique that quality testers use called pairwise, and it includes two basic things. I don't want to dig too deep in them because some of it's math related, but orthogonal arrays and all pairs tables with tester's choice. And so when you combine exploratory testing in the process, all pairs takes like, a table, rows and columns, and some of those fields have like question mark. And so you can fill it in like, decide which type of test result you want for that, and as you're going along, so you could change that. And yeah, that's really going to help. I think like people talk about fuzzers or fault injectors, and I think Larry Sudo did a paper where like 30% of applications were covered by typical web application security scanners, and fuzzers have the same type of results. In fact, like most automated testing only gets about 30% coverage of an application. And so like 100% coverage is ideal, but you're probably never really likely going to get there. You should check out Charlie Miller's work on fuzzing and code coverage. But what's interesting about all pairs and orthogonal arrays is that it can increase the coverage by maybe twice that, maybe 60, 70%. So you're getting a lot closer to maximizing the amount of tested inputs and detail in your applications. So this is where we're going to kind of go through the life cycle. I'm going to go through it backwards because typically when you talk about a secure SDLC, you got the steps forward. But typically, I think that we always work from the outside and not from the inside because we're security professionals. We're not developers, and we have to really work from the outside in. A lot of it is reverse engineering. A lot of what we do, we don't have access to the source code. We're not the ones developing it. So I'm just going to go through kind of the phases of the life cycle in terms of like what quality testers usually do. But just keep in mind that I'm not doing this in the right order. Normally what we start with is operations testing or maintenance testing. It's kind of like after the product's already been released. And fuzzing with code coverage is great. Like I said, check out Charlie Miller's stuff on that. Web application security scanners, that's all like runtime outside of the application, etc. A lot of like financial companies, Gadi Avron talked about this at like 23CCC. They fuzz before purchase, and so before they purchase an application or before they decide on using like an SASS product or whatever, they're going to fuzz test it or run a web application security scanner against it or whatnot. Then there's acceptance testing, which is usually like user based, but from a security perspective, you don't really want to involve the users quite yet. But Selenium is a good approach to that. I like that approach a lot. There's some tools that will help you with this that some vendors have released, like HP DevInspect, IBM AppScan DE, as well as like a few others. Like I think CompuWare has a bounds checker and security checker tools, which will kind of like work at the acceptance testing layer. So this would be for people who want to fuzz their code or fault inject their code before they actually release it. And so, while security professionals are going to do that stuff, there's other things that developers can do or that you can help developers do. I'd like to see a lot of those types of tests translated into these types of tests. But the idea is that during integration testing, when you're actually building the code, so a lot of companies have like a nightly build or weekly build process where they build the code and make sure it actually still compiles and works and functions all together. And even if it's not a compilable language, they just want to make sure it works with the database and with the internet. Maybe it's a staged environment. Maybe it's like some type of QA environment. I think the web test is probably one of the better tools that works in this type of area. So it's tightly integrated with the actual build itself. This is a kind of a gray area, the next one, component testing. Not too many people know about it. Many people still call it just unit testing. But the idea is that you can work with just one component of the application. So if you make it really simple, like you have an internet side, like a web server side, and then like a database server side of a web application, you could mock up or like use a virtual mock, which like is just a fake or like a stub. That's what they normally call, like basically like trying to make the component appear like, appear available without actually like having a full environment to test. And some of these tools are run as integration type tools, but it's kind of like a whole system integration test would involve testing everything, where some integration tests are also component tests. So it's kind of a gray area, and then some of the tools don't run in integration, they run inside the IDE. Like Jetty is like a server that can run in like Eclipse IDE or whatever. There's a Selenium server, this is an interesting project that I just found out about too, which runs